is covering a wide range of topics. This year we have 170 reports, 170 presentations, and that is a pleasure and this is a joy to have this opportunity to exchange opinions and exchange information. For developing their own research and science and gain support. We do have many things to boast about. We've demonstrated great results and people from other universities express their high esteem, and colleagues from Moscow University also come over to Tuzur in order to figure out what is that we do that we become the winners of different programs. For example, the Priority 2030 program for the industry. Not to mention, not to stay here with this chart for a long time, but some students might not know about it. Nevertheless, our main technical characteristics are presented here, and our university is a unique university. This year we have increased the number of students, so at this point we do have 12,900 students. And what is unique about our university is that we do have contained applied sciences centers. Tuzur was one of the first universities creating the Students' Business Incubator in Russia. Back in 2012, we created a nanoelectronics research center, including the first REC cybersecurity. And as always, we're being technical people, we are looking into efficiency, and we do like to look into the numbers. So it's also key that the majority of our revenue is being generated independently by using contracts from and so on and so forth. And as any other university out there, we're ambitiously setting a goal within the 2030 program. As I have already mentioned, we've become participants in this special part. We're in the second group. Only 30 universities are included in this program. And we are somewhere categorized as from 1st to 6th ranking in the Russian Federation among other universities. Just that you understand, the total of universities in Russia amounts to 730. It's for you to understand this number that we have put very high stakes. We're very high above in terms of ranking. Just recently we've started to doing the intermediate report on our 2030 target program, and as any other university, we are looking into increasing the number of students, increasing the budgeting. As I have already noticed, we would like to be 50% of the applied research for our revenue, and our main strength is generating applied research teams, innovative teams, startups and businesses. And we hope that by 2030 we will have at least 50 companies a year. You probably heard that just recently a new IT space, IT park called Gerzen was just opened in Tomsk. It's a private IT park in dialogues with our companies. By all means, every product of the priority 2030 has the key growing point or points of growth. And we have identified 4 main strategic projects, which are as follows. The fundamental project, the one that I consider our key core area of work, which is microelectronics and systems of new generation. As far as I know, at least 10 research teams are working within this project, and they're working on new educational programs. Also looking into business partnership with our industrial partners and research organizations that are demonstrated below. As our second strategic project, I'd like to mention another important area, which is IT, security, digital security, and cybersecurity. Another one is space sciences and engineering, and the next one is what we call the brand new area is greenfield or biotech. The fifth area is more generic or generalized one, is included into the big University of Tomsk program. Also, we see key points and UHA, microwave testing grounds. So it will be a new approach, a new sort of facilities, student facilities for photonics, nanoelectronics, that will be help to form new schools and new production facilities so that we can enhance our sustainability and our chance to be independent from foreign contractors. So our university has a status of organization that has licenses for military and other government-related bodies licensed. That is a OPK or OPK status that is an honor. It's a very serious achievement, and it takes efforts to hold it. Also this year, we are opening a digital academy, which I will also cover a little more. A center for cyber security has been opened. A new research and education center of cosmic technology and engineering is being worked on. We've designed clean spaces of all types of energy for using. We can use it for aircrafts, for lithium-ion batteries, design and production and testing, and different types of energy generation and energy for space vehicles. The head of this project is coming over to Tuzur soon to get acquainted with our university and our research. And we've been able to organize a tour for the representatives of the Polus companies, and we are getting ready for this tour in order to demonstrate what we're worth and what we can offer. Since we do have a lot of partnership with businesses, and not only with businesses, we do have a lot of independent contracts. We all know that we're now living in this new digital world. Within the framework of the priority programs, we will have a new strategic initiatives opening offices in one of our buildings, and this is a digital academy which in fact will not be a completely virtual thing. It will be a big office, a large initiative. We will invite our graduates, our successful graduates, that will help us be on top on the new IT competences. So our students will have a chance to get new knowledge fresh from the industry. We encourage all of you to participate, and we encourage all of you to apply to this program. In order to improve your knowledge, to improve your competencies in IT, whether it will be digital device, try to get the faculties, but of chances to use facilities, to do better networking, to use facilities of other universities. So I encourage you to take advantage of this program and get familiar with other universities. Also, it's a chance to get courses in other universities. We're working on it free of charge in other universities. Also, starting next year, we will have a certain number of spots in the what we call military faculty. So it's during the design phase, and the sizes for the radiators of thermal regulation. So such materials are very useful for design of space vehicles, but they are less stable. Over here, you can see it's for the 36,000 kilometers. And by the end of the journey, that are being used in space, they already exist traditionally, and among them we can choose the one that we would like. OSG 9. The emissions to measure depending on how the microcontroller functions at different temperatures. For specific cases, for our Russian microcontroller is the curve or the trend to the left, or the other one, the plastic casing, is to the right. Several other testing has been done. That is where we had the simulation device with the screen in the screen chamber at normal temperature. The minimal amplitude was 700 volt. for the main program and the testing for the address space of the flash memory. Other measurements including the TM chamber using a special adapter, a coaxial line, and consequently here we did testing using the grant program for the Russian Scientific Union and other state grants. Testing that we did using different temperatures allowed us to unite into one device called a climatic screened chamber. The microcontrollers at a set temperature inside the chamber. This is how this prototype of the climatic screen chamber look like. It looks like this. So partially it's functioning already. It is functioning, and separately you can see the patterns and the systems or the door, the model of visual control for biological testing. Besides, we are actively working on the GTM for gigahertz range, both open and closed. Again, enabled to be tested bigger, larger devices, so larger equipment systems and units. It is more effective. We also have been working on the strip-line circuit. The strip-line circuit has been developed with the federal program, and this is a power bus line that has to be tested. We have simulated the bus line, power bus line, created a methodology in order to calculate it, and then we simulated the conditions. About the stripline circuit, we also worked on simulation on the model, filter, resistance to external emissions. You can have more information in the article that we published about that. And the last device that we designed is a coaxial chamber, which allows us to measure the efficiency of screening of different composite materials using two types of standards. Generally, the model of this chamber is demonstrated to the right, and the model of the electromagnetic wave distribution is to the left. Measuring the composite material electrical effectiveness is another piece of work that we did using different gaskets. For example, a brass gasket or other gaskets that have to be assembled in order to figure out whether it's possible to be used internally. Our customer asked us to do that for medical facilities. So that's the work. Also, the third one was provided by the Tomsk State University. The results are demonstrated on the chart. The complex of all the measurements was categorized in a separate software. Also, we're working on a module that will be providing now the recalculation of the emissions dependence, acoustic chamber, and recalculating them. That all has been used for the synthesis and testing of the optimal network of the high voltage network. Well, that's about it. Thank you for your attention. Thank you so much for your presentation. Do you have any questions? Yes, I do have a question. Mr. Komnatov, you had one term called the spiral cross section. Can you please share more about what that is? Over here, well, the bus drive, you can see that the power bus line is here within this project. We did it as a screened transmission line. So this shaft here is inside the axial line, the dielectric, and the metal around. This has been done in order to be able to transmit up to 20 kilowatts. And based on this power bus line, we've created a transmission line that will have a spiral cross section when two conductors are being connected in spiral with each other. The question for clarification, can you draw it, please, so that we understand it better how you do the spiraling with the conductors? So that's metal. This is a dielectrical material. So they will be flat. Will they be flat? That's how it, in 3D, that's how it will look like. I'm just curious. That's the spiral in a cross section. It has no intention to talk about the testing devices. It's just the conductors that are being rolled together in a spiral way. So that's what it is. May I ask you as a question, please? Some of the charts or the slides on your presentation showing the strip line circuits, you are talking about the line law of changing the width. And we know that the sum of the irregular transfers have a shorter alignment area, but you are not using it, or do you have some technological restrictions, maybe limitations? Right here, we're using a line expansion with the exception of coaxial chamber or coaxial cell. We made it more compact due to the law. Why can't you? Yeah, that's what I'm talking about. Why can't you use this principle that we can give you a better alignment? You can use a smooth transfer or smooth transition. Do you think that there will be some technological limitations? I think there will be, yes, so that's why not using. Another question. You have to make the homogeneous field inside the chamber. So what requirements do you have to fulfill to consider the field, the electromagnetic field inside the chamber, homogeneous or even? The homogeneity of the field is around 3 decibel for the TEM chamber, TEM cell, the 20 millimeters height, and the KSW should not be more than 125. And chart 18, you said the amplitude was 700 volt, and what about the duration of the impulse? That's seconds. Please use the microphone to ask your questions. Good afternoon. The question is about the software product that you shared. You said that it was developed. So please, can you share what is the name of the software product, and do you think it could be go to the open market? You could market it at some time soon. Yeah, it just has been developed recently, and this software will be presented in two ways, either a part of the TollGAT program software module, or another option is that it first will be open for beta testing, just for students as well, the students who could be able to use this program, use this software, model it, then do the laboratory work for their training, and see if there are any bugs or something. But we need to initially test it before it goes to the market, to the open market. Thank you. Is my understanding correct that this software does not have any value without your chambers? Well, the model using using the standard Shelkonov's model, using the geometrical parameters and other parameters, but the rest for the chambers, there will be special windows for information for the chamber properties, and they will be useless. So yeah, it's kind of in line with our chamber. Let's thank our presenter once again. Thank you so much. Dear colleagues, the last presentation will be done by Alexander Tsesulin, Doctor of Engineering and Deputy General Director for Research Institute of Televidenia or TV. I had an honor of presenting here at this conference 4 years ago, only 1 year, only one time, so I didn't have a chance to talk about the Institute of Television. So what is it? I will have to now talk about the very beginning, from the very beginning, and I have a suspicion that not many people know a lot about our institute. Television is being linked to television transmission or broadcasting, TV broadcasting, but TV for gathering or collecting information is even more important than broadcasting. So I had to take a special picture. That's the picture I took. That's Korolev, and I just wanted to show you how Korolev has this television at hand. This had to be really recognized when our university was first established. Igor Vasilevich, who was a director, and actually had the honor of working with him, and he once published an article in a newspaper called IC, and I broadcast. At the same time, Norbert Wiener was saying that the human is the most the slowest linked in the system of control, of system of management, as you will. In 1935, whom Tsiolkovsky called our Soviet Jules Verne, Alexander Belayev made a prognosis that how the development will go, how will the development of scientific institutes will look like. So that's what happened in his novel in 1935, and then our research institute was established in 1935. This is a document, the regulation. It was the main principle: 80% of civil and 20% military duties, labor and defense. And in the very bottom, you can see the Stalin, Ordzhonikidze, Voroshilin. So that's what we called the forwarding list of that time. Who was informed about it? It was a very important and promising sphere. So the main achievement of our institute is the cosmic television, space television. The technical task that was signed by Korolev was signed 1 year or even more than a year before then the artificial satellite was first launched. So he planned starting the airspace television even before 5 quarters before that first satellite. So the first satellite was behaving rather erratical in the space. Korolev himself had created this technical task that was supposed to be showing a small volume where the astronaut or cosmonaut is sitting and demonstrating the view of the Earth. Let me quote Korolev because that's the best quote ever. If you set a rocket to space without any television devices, it's the same as using a sling with a stone in the medieval ages. So, in time of the Yenisei launching into a space station Moon 3 or Luna 3 that is now in the museum, and you can see an edifice or a hall on the picture to the left. That's our Yenisei device. All of this was created under the leadership of Pyotr Braslavets, the creator of Cosmical TV. There is actually a medal named after Pyotr Braslavets. He is a creator of cosmic television. Cosmic television, it's one of the first pictures that is widely known is how Yuri Gagarin was in space. Korolev said that he'd like to have a sneak peek of how Gagarin felt in space. So that's how the sneak peek looks like. It was the first camera. It only had 100 lines and it was very slow, but the goal was achieved. There was a picture. There was a sneak peek. At this time, our research institute is designing and producing, manufacturing a wide range of cosmic television system. Very often, you can see the footages of how shuttles align with the cosmic stations on the international stations, and that's footage could probably be also taken using our equipment. That's the shuttle coming to the station. Also, you can see that the astronauts or the cosmonauts are steering this apparatus, this device. To the right, you can see this is one of our postgraduate research students who was checking how apt he is in order to control such devices. It's quite a difficult and challenging task in order to align the shuttle with the International Space Station. That's a different view from a different angle. So a person is sitting and shuffling uh, different controls. This is how it looks like in real life. On this picture in the bottom left, you can see the shuttle. To the right, bottom right, is the camera that is installed on the International Space Station. That is, you can see it's wrapped around with different materials, like mentioned in the first report today, in the first presentation today, special space materials. And on the picture to the right, you can see how the discussion of parameters of the perspective television system to control the parameters of alignment between the shuttle and the international. The axis has to be aligned, so you can see if the angle is wrong, then the cross in the center is not in the right place. The next point is space sea ships or vessels in the oceans. So it's another important part of our work. So this ball that you can see, this is an antenna actually. Another one is also an antenna. The point is, you can't really wait for the internet to tell you what the weather is going to be like, and you have to be able to gather information from the closest satellite. There you can see the curve of the trajectory of the path of the satellite. So you have to be able to figure out what is immediately going on around you, what weather is around you, around the ship. So about the Baikonur and other space centers, the antenna that you can see there is quite a difficult, or it's quite a challenging mission, and it's this antenna is tracking one half of the sky, and then it has to turn around, and you can see that it's actually turning around. It has been a testing of the complete spins in order to make a 180-degree turn. Also, such antennas can be found in many locations in our country, and all of the infrastructure has been developed and implemented by our research institute. Both the stations of space connection and such smaller minor things such as a video monitoring of perimeters for highly classified facilities. We do not mention them there because it will just then make it too many facilities to mention. Also, we understand that the unmanned vehicles is another two-way streets that has to be both defending and controlling unmanned vehicles, and that's, you can see the astronauts, the cosmonauts, rockets in the sky. Everything is being broadcasted by our research institutes, over 100 TV cameras. And quite interesting to see the element is the connection with a starting shuttle or starting space vessel. It was very interesting to listen about electromagnetic compatibility, but electromagnetic compatibility can be tested very easily, or at least relatively easily, on Earth. We can simulate the conditions. But the question is, how does the plasma of electromagnetic engine influences the electromagnetic this ship? It's a serious question actually. So that's the first step is being drawn. So it has to be discharged while still having the fuel in it. Otherwise, it will be out of control. So it has to be disposed still burning the fuel. That's a long movie, actually, a long video, and let's continue. So the first launch of that rocket from the Space Center Vostochny was attended by Vladimir Putin. So you can see how important and significant that is for our government as well. And the second part, just as Alexander Belayev told us in 1935, space and the depth of the sea. So several pictures here about using TV equipment to be able to control the takeoff and landing of the jets, of the planes, from the sea vessels. Over here you can see the bolts, and here on the left it's the camera itself that will help us to control the landing of the jet to the ship in the ocean. That here you can see that there are different angles that allow to control how the landing or the takeoff, in this case it's a takeoff. Yeah, there it is starting. Over here you can also see how it's starting. Okay, that's enough. That's now it flew away and now it has to land. It can do the steering more or less right. Just not to miss the aircraft carrier ship. But in terms of the height or the glissade, that's a special term, it's very difficult to understand. So the officer who sees that, this picture, he also tells the pilot how to adjust. So it's another control system, a very applied control system. So yeah, it landed safely. That's a curious picture. It's an interesting picture. Sometimes you ski what we call the skid marks, the skidding tracks. Next to our personnel, you can see the skidding brakes, the brakes lines of the first jet that landed on this aircraft carrier ship. That's an interesting thing to do. So I was talking about the service equipment, but the theory and technology of control is something that TV by itself needs as well. So that's where the control system for the research institute that we developed and designed, and it enhances our opportunities. What does our customer say? Well, he says that we do have a close distance. We have to see a very close distance monitoring so that there will be no incident, no collision. We are trying to give the customer what they want. So, giving both very close up and a wide range picture is not an optimal solution because there have to be different solutions for close up and for long distance TV system. So you can see there are different frameworks that make it possible to enhance the ranges of the more distant objects and to be able to react to the close-up distances. By the way, Alexander Belayev, this writer who wrote this book in 1935, in his book he's saying that one of the space pilots was not able to control the shuttle and there was a collision. So that situation was quite described by Alexander Belayev. Anyway, complying with the wide requirements can only be possible by adapting. So other adaptation that is the long distance view of the spaceship. So that's the star. These around are the stars, and we can see that as the spaceship is coming closer, it's becoming more. It's becoming brighter and brighter, and as long as it's closer now, we can now increase the frequency of the frames per second. So more frames per second. See, that's the adaptation of the frames per second. So by adjusting the frames per second helps us to make the control systems safer. The next element of the control systems is a classic situation for the middle distance. That's how we see the approaching spaceship and the Earth is in the background. You see that the background is something that we never need. Nevertheless, okay, that's a different video. I have to go back. So the background, we do show the background and we're using our bandwidth for that. So we decided to use the contour of the spaceship, and the rest of the background is compressed by hundreds of times, as you can see. So the vessel itself is not compressed. So that helps us to better utilize the bandwidth and increase the frames per second and decrease the delay, the lagging of the transmission. So that the whole concept of the adaptation has sometimes faced the challenge. For example, if we take the camera of a very good quality, like 20 MPS in the most smartphones, we cannot make a good bandwidth. So sometimes we had to play with the frames per second in exchange for it being more sharp, so to speak, sharper. So we alternate the signals, alternating signal sharpness or frames per second, also adapted, and that's like a concept of total adaptability of all the parameters. And what are we working on at this point of time? Currently, to the left is a submarine vessel, which is unmanned. It's a modern apparatus. It could be used to be looking for the cables, for example, the underwater cables. And we also have a professor here who is working about that, who's been working on that system, and he knows more than anyone here about how urgent and how burning this issue is. The next picture in the middle, it's what we call underwater motorbike, and it has different cameras and different types of features that allows us to see underwater better than the human eye can see. Our main problem with the water is the transverse reflection and the back reflection. Transverse reflection is the biggest challenge. It's the biggest challenge, and there are only three ways: changing the spectral range, or RGB, or blue and green, separating the transmitter and the sending signals, and stopping. And unfortunately, we cannot use the separation quite effectively because the sending and transmitting and receiving units cannot be put very far away from each other, but we still try. And this picture on the right is the laser. Kurevich here, Piotr Kurevich can tell you about how such systems work. Laser locations, laser connection, and this connection is being provided for the two satellites in between each other. So it's a duplex connection, two-way connection. Those are our main research projects. And to sum it up, I'd like to also mention that many things that I just presented to you is being done by our younger generation, and for this more senior generation here, I would like to say that it's not only I see, I transmit, or I broadcast, but our research institute is a part of Russian agency of the control system. So we are in very close range with Tusur. Thank you so much. Maybe someone has any question? Does anyone have any question? Uh, what is being done for the far distant space in terms of research institute TV? The the distant space is being monopolized by Moscow organization, for example, Institute of Space Research and others. And some time ago, Alexei Bogomolov was an owner of this center for the fast distant space television. So our institute does not do the far distant space. Another question. You said about different project that you're working on, researching. The question is how what about the import substitution and the availability of different components? At this point in this situation, the Russian components are not enough for us, so the situation is severe, I can say. It's very poor. So our institute was trying to work with different facilities, and we're now working on the design center of the system level. And in fact, for the photographic receivers, um, other companies, Pulsar in Moscow, Neo Electron in St. Petersburg, with its affiliates such as Alara and different other. And we are only working on the first phase of design, so we do not facilitate the components sometimes for the. And we also need the radiation resistance to radiation. That's another thing that has to be a parameter for our components. We have designed 2 megapixel and 4 megapixel matrices, and the company LR also designed and developed a camera, and actually it's a good one. They put it right away in the case in the Montpellier fridge. Many companies are using them, but there are not so many manufacturers. And another thing that I can help myself with, and you said the Mikron, the company that is located in Zelenograd, in Moscow region, and I told to the main designer, Shelepin, engineering designer, about that he said we need 300 million for research and then we'll talk. Why? Because we can do the digital frameworks, digital chips, but the libraries for electronic libraries for manufacturing the photo receiving metrics are not existent. So that's how it is. Everything was being manufactured in Malaysia. So Micron is covering the digital, uh, our digital components, but the matrix is not something that they're doing right now, and we do not know when they will be able to do it. Another question about the 80 to 20. You were talking about 80 to 20. Was it 80% civil or 80% military? Yeah, 80% military product, 20% civil. Can you talk about the civil use of your research? The civil, the peaceful, as we can say, use is something that we were lucky about, because some of the control system are considered civils, and the measurement and control for the TV stations is something that we have been evolutionary working on. So the TV station or TV centers are just telling us what to do. Better do this better, enhance that, improve that, and also we are working in terms of civil usages, the medical diagnostic devices. That's it. Any questions more? No. Thank you so much for your presentation, Professor Sitsulin. All right, dear colleagues, I'd like to thank you. We now have listened for very interesting reports during our plenary meeting. Our conference will be lasting for the next 2 days, 3 days in total. So I wish you fruitful work and interesting technical solutions. Good luck to everyone.